just to kind of give context of another giant number, is this is the equivalent of everyone going from San Jose to Austin and back, everyone in the United States, 1.65 times. So just a mammoth number. So let me talk a little bit about Arrive. 2.3 billion in revenue. So this is another one of those big companies that nobody's ever heard of. We're the fastest growing third-party logistics provider, organically growing third-party logistics provider. We have our HQ here in Austin. We have locations in Chicago, San Antonio, Tampa, Guadalajara, Mexico. 1,500 employees, 250 employees in tech. And we are going to hire more than 3,000 new team members by 2025. So we're growing at a pretty fast clip. It's a really exciting opportunity for me to be a part of. I'll also say I'm looking for a senior ML engineer, and I'm looking for a data engineer if anyone's interested. So please come up and have a chat with me or any other team members that are from Arrive here. I'll also mention from a positioning perspective, like what are the problems we're trying to solve? Arrive is focused on what we call this co-pilot model. And so we're building technology to empower and augment the capabilities of our people, not replace them. So those relationships, that connection is a critical part of our industry, and we're never going to be able to walk away from that. And so taking advantage of technology to improve and enhance those capabilities is kind of our key driver. Okay, I used the word third-party logistics provider. Probably none of you know what that means. So what is a third-party logistics provider? It's a logistics company that has basically no trucks. And so, and we heard in the previous talk from Indeed about marketplaces and platforms, pretty much the same kind of problem to solve. And I'll talk more about kind of this matching problem in a moment. But this is about finding, for a given shipper, trying to find the best carrier to move that shipment and do it in an optimal way. And I'll talk more about what optimal means. But I'll contrast third-party logistics providers to asset-based companies. Those are companies like C.H. Robinson and other very large companies that they have their own fleets of trucks. So they're kind of the more traditional carrier. And kind of the third is another set of carriers that are what they call private fleet. So Walmart, Target, Coca-Cola, they have their own trucks. But they can't use them optimally unless they are working with other companies, because they need a load to go from A to B, but they then need to go from B back to A. So how do they do that efficiently and effectively? And that's one of the things that logistics companies solve for, especially third-party logistics companies. So what's the first problem to solve? I'll split it into kind of the shipper problem and the carrier problem. What does a shipper need to do? They need to maximize performance. They need to have their warehouses effectively used. They need to have on-time delivery, on-time pickup. They need to have the material move when it needs to move. It needs to get there at the time they expect it to. No delays, no disruptions. They also need to do that cheaply. So how do I minimize the shipping costs associated with this? And an example is, find me a carrier that will pick up high value, hazmat, hazardous material, load from a warehouse in Newark, New Jersey on January 10th at 12:30 p.m. and deliver to a warehouse in Carson, California on January 16th by 10 a.m. So that's like a very, very specific example. And so what are they looking for? They're looking for carriers that support their equipment. So you want a standard truck? Maybe you're shipping vaccine, which we did a lot of, by the way. And so you need a temperature-controlled vehicle. Maybe you have an oversized, I don't know, something to do with housing or something like that, that needs a larger truck that is a flatbed or an open deck truck. So these are the kind of the constraints around recording this required equipment. They need to have a truck, right? If they don't have a truck, then it doesn't matter, right? If all of their trucks are used, you're not a viable carrier. So they also need to meet regulatory requirements. you're shipping alcohol, you're shipping in specific states. These are all kind of constraints around what you can and you can't do. As I mentioned before, in terms of maximizing that performance, they need to be able to deliver predictably and reliably. And then lastly, as I mentioned before, cost. Can they do it at a reasonable rate? So now let's pivot to the carrier problem. So I have shippers over here, carriers over here. And so what does a carrier need? What problem they're trying to solve? They're trying to track and meet the regulatory requirements. So things like hours of service. So how many hours does a driver it permitted to drive continuously or over a specified time period? Of course, they're trying to maximize their revenue, minimize their cost. They're also trying to minimize their time spent driving empty. So that's ineffective use of their assets. And I'll talk a lot more about that in a little while. And they're also looking to try to have repeat business and develop a positive relationship. I'll talk more about why that's important as well because of the imbalance between these two sides of the market, the carrier side and the shipper side. So they're looking for shippers that have reliable and consistent freight. They want to help to maximize their usage of their assets by having freight kind of close to them or in the right locations. They want to have reasonable rates for shipping things. They want to be paid well or reasonably. And they want to be able to have someone that can do business with easily. So I talked about this imbalance a moment ago. So we have 1 million carriers and 4 million trucks over here and thousands of shippers. So how do you kind of create that match? How do you find a connection that satisfies all the things that the shipper wants and all the things that the carrier wants and do it real time because everything, a truck comes and goes in minutes. So all of these things are happening in real time and things change. As you know, I think there's a set of giant storms that are happening right now, which is causing all kinds of havoc in terms of availability, changes in loads that were in progress or canceling things because of that weather conditions. All of these things need to be handled and addressed in real time. And this is where the human element comes in, by the way, because the algorithms don't deal with that all that uncertainty associated with storms and other things very well. But we do well on kind of the standard problem, and I'll talk more about that. So, how do you find this best match? Well, we need to ensure our regulatory requirements are met, provide the shippers with the required level of service, minimize supply chain efficiencies. What does that mean? Well, if I'm a carrier and I'm based in, LA, and I have to go do a pickup in San Francisco, I'm going to be driving empty a significant percentage of the time. And in fact, we'll see later, that happens a lot. So how do we minimize that opportunity cost? How do we minimize the costs associated with the fuel? How do we minimize the cost of the driver, minimize the cost that's associated with the wear on the truck? And equally important, the sustainability impact, the greenhouse gas emissions impact of having that truck drive empty needlessly. How do we optimize that? And I mentioned this before, these things are happening in real time, all the time. And so any solution that we implement needs to be low latency, highly scalable, because we're talking about thousands and thousands and thousands of shipments that are happening every day. And I mentioned before, 4 million trucks, 1 billion carriers, thousands of customers. How do we scale that up and provide real-time answers at low latency, also with comprehensive data? And it all comes back to, everyone talks about this, it all comes back to data. If you don't have the data, it doesn't matter. You can have the fanciest algorithms in the world, it doesn't matter. And so building that foundation of data and then building those solutions on top of that are low latency and highly scalable is kind of the key to this. So what does this look like? Well, we need to create this kind of recommendation engine. as we talked about a few moments ago from Indeed, similar kind of problem. We have a marketplace, we need to solve for this. So, key aspect of this, feature engineering. Geographic information is a real pain, but it's critical. And I'll also say, go ahead and look in El Paso at all the zip codes in El Paso. There's one El Paso zip code that for some reason Google thinks is in the middle of Texas. Google gets these things wrong. And they have cars driving around doing this all the time. So I found early on that for geographic information, accuracy is not what you're looking for, consistency is what you're looking for. And so I just call that out there because it's a significant problem and it's a hard problem to solve. We also need to do analysis around the carriers themselves. What do they need? Where are they available geographically? Where are they situated? Also the load characteristics, understanding the different characteristics of that shipment. And I'm using the term shipment and load interchangeably here. And so we have kind of these features that go in. We have these constraints around regulatory shipper service requirements. And if you don't demonstrate the ability to meet on-time delivery, on-time pickup, et cetera, requirements, you're not a viable carrier, no matter how good the algorithm thinks you might be. And specifically, do you have the equipment that's needed? So incorporating those constraints, we can basically, as you might expect, it's a binary classification problem. It's actually multiple binary classification problems. And then we optimize those results to give a specific set of results. What are the challenges? I already talked about geographic data. It's a challenge. It's fun. Other people in the audience, I'm sure, have had this experience. We're also combining multiple models together, and I'll talk a little bit more about what that is. But then also just defining the training data. What is a success? And how do you measure success? Especially when you have maybe 10 good matches. And it is perhaps difficult to tell which one is best. So, how do we address these challenges? Well, I didn't. It was Kathleen, and Kathleen is amazing. And she took all of that load information, applied these geographic transformations, a novel approach that she used to look at weighting based on distances and doing this similarity analysis that she developed to create specific features. Then took carrier information, including that availability description I mentioned before, those constraints, again, those geographic constraints that are associated with those carriers. Combined that with these two models, one that we call a precise model, which if the carrier gives us information about, I need a truck to go from A to B, that's one model. But sometimes the carrier will say, I have a truck, it's in Austin. It can go anywhere. They don't actually mean that a lot of the time, but that's the data that we have, and so we have a different model to handle that. And then we combine all this information together to unify the results of these different models and then provide those match results. And this all happens in seconds, has to. And it's continually refreshed as we get new information throughout the day. And so as that new information comes in, these calculations are recalculated. And so, okay, by implementing this, what have we seen in terms of impact? So we started to do this analysis. Another data scientist on my team put together these results. Muriel, her picture isn't on here. Sorry, Muriel. But what we were able to see is that we've been able to reduce emissions versus kind of the industry standard by around 50,000 tons of CO2 last year. That's amazing. And it's what's especially interesting about this, if you think about any other industry, almost always as the industry, as that company grows, actually their emissions tend to grow too. We're in a unique position, us and maybe solar manufacturing and other things like that, but we're in a unique position in that as we grow, we make the supply chain more efficient. because we have these algorithms that are allowing us to optimize these things. And so as we grow, that number is going to get bigger. So I personally, I think that's super cool that I got to be a part of that. Also, I didn't write this down, but I'll tell you all and the internet. This also leads to around $1 million a month in incremental profit. So sometimes helping the environment and being more efficient can also be incredibly profitable. So talked about the matching problem, talked about connecting carriers and shippers, but that's just kind of the first step. So I pick up the phone and I talk to that carrier and I say, will you move this? What's he gonna say, or she gonna say? How much? So what's the number that we give to that carrier? Well, we need to effectively determine this cost in a very fast-moving, dynamic market. And so if we do this, we'll be able to be more competitive in the market, continue to grow, continue to drive efficiency in the supply chain, and continue to drive down emissions. But what are the cost drivers here? Enabling carrier efficiencies. So supply and demand, economics 101. You have a lot of trees coming out of Oregon for Christmas. Guess what? It's really cheap to get a truck into Oregon. It's really hard to get it out because everybody wants to get out. Vice versa. And this happens all the time. And depending upon what's happening at the ports, what's happening in specific seasonal conditions, all of these things matter. And all of these things drive prices. And that can be the market. Right now we're seeing a downward trend in a lot of the costs that are associated with pretty much everything because of reduced demand. But there's also geographic dynamics that I mentioned before. So all of these play into what the cost will be. So how do we go about doing this? Well, we need to enable our cost effectiveness or cost competitiveness, protect against market volatility. You don't want to be the person who needs to deliver something from point A to point B when the price doubles. You don't want to be left holding the bag to cover that. You need to understand what your costs are going to be in the future. You need to understand your cost variability. So what is the risk you're willing to take to accept, say, that load from Coca-Cola or Walmart or Target or wherever, and be able to deliver that. And also, we still have all the same problems I mentioned a moment ago, because I got that truck match for that carrier, but now I need to know that cost as well. There are also specific marketplaces that are purely API driven, where the SLAs, the expected times for completing a quote, is measured in a second or two. So all of these systems need to be very low latency, very highly scalable, and again, comprehensive data. All comes back to data all the time. So how do you go about solving this problem? Geography, you're never going to get away from it. So need to have effective ways of leveraging geographic information, geographic variability, timed variability, combining that information together. I think one of the things that people don't think about when they think about these kinds of problems, there's an incredibly long tail. So yes, you're going to see tons of shipments between specific ports to other main cities. But you also have shipments going from Baldwinsville to Grapevine, or random other place in Nevada to random other place in Nevada. And so what data do you use to effectively predict what that cost will be? Likewise, you might have a hazmat team's same day load as well in those specific very sparsely generated very sparsely populated kind of data areas. So, challenging problem. Including those load characteristics I just described, including the shipper characteristics as well. So some shippers have more challenging facilities to deliver to. And guess what? If you ask a trucker to go to a place, they don't treat truckers very well. They charge more. And which is, internet, you should treat truckers better. It costs money. So I would say that, incorporating all this information together, generating effective features associated with that, putting together, and this should say a percentile-based system to estimate cost variability. But we're using standard tree-based methodologies and some unique methods to estimate that variability component, which is so critical, and understanding kind of how to handle that very sparse data set. So challenges include, how do I do that? Feature engineering, incorporating all that information together, and that long tail I mentioned as well. So again, I didn't solve this problem. My friends Andy Davis, Colin G, and Andy H contributed to the solution. And what this does is, again, takes that load information, does that geographic transformations, incorporates that carrier information, incorporates the shipper information, incorporates the market information as well, and uses that to predict the cost. And what does that do? That allows Arrive to be more competitive, reduces our risk, and drives our growth. Okay, so summarizing. The freight trucking industry is mammoth. It's kind of this invisible thing of the economy that has such an impact on everything. 875 billion in costs, 11 billion tons moved. It also has a significant impact on the environment. But we found if we use real-time scalable data science models for matching and cost prediction, we can optimize supply chains and have a significant reduction in emissions. Now, we're just a relatively small piece of the industry, but as we grow, we'll be able to continue to have that impact. And then lastly, I'll just mention from a philosophical perspective, the way we're looking at solving these problems is not by removing people, but enabling people to take advantage of these solutions, because we're never going to get rid of that relationship. That's always going to be a value to connect with our shippers, to connect with our carriers, to make sure that we understand their needs, and then augment what our team can do and enhance what our team can do to help them. Thank you.
Hi, Alex. Amazing talk. It's really impressive to see the positive impacts on both the profitability and environment. My question to you is, I'm curious about multiple destination kind of scenario, and if you've, I wonder if you could share your approach on that.
Great question. So there's kind of multiple ways to handle the problem. You can kind of handle it in a simplistic way, that basically treating this as just a longer haul, right? If you're going from A to B, B to C, C to D, then you can treat that as going from A to D. And the time and the miles are just kind of incorporated into that model. And so that's one way to solve it. And for a cost prediction kind of application, you can kind of do kind of a multi-layer approach where you understand how many stops there are, and you can understand the kind of the overall, that A to D portion, and kind of combine them together. From a matching perspective, it's a very similar kind of problem, because you want to understand, really from a carrier's perspective, I don't care. It's going to take this long. whether you make me stop or not doesn't have as much of an impact. But you want to be able to know, because some carriers will find that less desirable. And so understanding that that carrier is not willing to do it and this carrier is, you can kind of incorporate that in your matching algorithm. Does it make sense?
Hey, Alex. Jack Bowen from Kung Fu. I really appreciate the talk. I was curious, we work with some folks in the factoring side of the equation, and they are anticipating a large upspike in fraud this year due to some economic constraints. I was curious what, if any, intersection you and your team at Arrive have with any of that sort of fraud on the carrier or broker side, and what your thoughts are there.
Luckily, I am not involved in that very much, but we do have multiple companies we work with that we vet our carriers. I mean, that's a big part of our work is to understand which are the carriers are the best carriers. And when I talk about kind of that human aspect, that's one of the things that we do is develop those relationships. And what we've also found is as you develop a deeper relationship with a carrier and you've vetted them, then that's more likely you'll be able to give them what they want. And if you give them what they want, then they're going to give you more advantageous costs, et cetera. And so that's where a lot of our kind of increases in performance and reduction and inefficiency comes from. Does that make sense?
Hey, thank you very much for this. I used to work for a 3PL back in the day as well, and this is awesome. Pricing was so subjective. On the customer side, the carrier side, people were just doing whatever they wanted, so seeing science get brought in is awesome. For the most part, it seems like this was being applied to the carrier side of things. Has there been any interest or use cases for the customer to maybe educate them? Like, okay, I know we did it for 3,800 last week, but there was a storm or XYZ that affected this, and this is why, based on this model. Has there been any interest in that?
Definitely. So that cost model that I mentioned is used for both the carrier side and the customer side, the shipper side. And so there's those API marketplaces I was mentioning, that's on the shipper side.
Okay.
So we can understand kind of what our cost basis is and then use that to assess what the appropriate price would be. And sometimes we win, sometimes we don't, because if we don't have the good carriers in the area and our cost basis is too high, then we don't win it. But if we have that relationship that I was mentioning before, we have that understanding of what the carrier needs, and we can find that great match between a shipper and a carrier, usually that allows us to win and everybody wins.
Awesome. Thank you.
Sure.
Hi, Charles from neurothink.io. As your team built out that predictive cost model, which sounds like it's based on decision trees, what was the baseline for what was currently operating to making those decisions? And then how did you go about choosing that level of technology? Did you have multiple options and go through some decision matrix and weigh some factors? And
Good question. It's very similar to what the gentleman mentioned over there. I'm sorry, I didn't catch your name. But yeah, it was very, very subjective. And if I'm the rep, so I have the responsibility for setting the price. And if I don't set the right price, I suffer. And so they use usually market information to assess, okay, well, what's the standard rate? Well, I can assume that I'll do about that, or maybe a little bit less, or last week I did this, or yesterday I did that. And that's a lot to fit into one person's head. And so we kind of looked at it to start with as kind of like there's a market rate, but then we kind of pivoted our thinking towards there's an arrive rate. And so that's really kind of our foundation to see our historical values about how do we go after kind of doing that cost prediction based on what we see in the market rather than some external benchmark. And in terms of model selection, we went through several different iterations of how do you incorporate kind of that historical information, because there's a time series component to it as well as kind of a more standard tree-based methodology. And so we kind of have multiple, and we have some people in the audience right now who have been part of this discussion. And so, and it's still evolving. We still see opportunities for improvement, for sure. Thank you.